To expand upon example 7, here we're going to verify more identities in example 8. So if you remember a couple of your identities here, you can't do anything with cosine, but your secant of theta can be rewritten as the reciprocal of cosine. So this is a nice, easier one. So what we get is a cosine theta over 1 times a 1 over cosine theta, and that just means that your cosines simplify, which is going to give you a 1 is equal to 1. So that'll give you your check for getting that correct. If you look at B, notice you have two binomials multiplied by each other, and these seem to resemble something. You have a plus here and a minus here. Kind of looks something a little bit, I don't know, like you've done when you had just variables. And if you have a plus and a minus, and these two terms are the same, and your second terms are the same, then you can do a difference of squares. So what we're going to do, instead of having this x plus 2 and x minus 2, because this equals x squared minus 2 squared, or x squared minus 4, what we're going to do is we're going to take our secant squared theta, make sure you put the square between your secant and your theta, minus tangent squared theta, and if that is equal to the right side, which is 1, then if you look back at your identities, we have this one right here, 1 plus tangent squared theta is equal to secant squared theta. So that means that we're going to be able to maybe use this equation right here, and maybe we can simplify this. So if we have a 1 plus, or let me move the other one, a 1 plus tangent squared theta is equal to a secant squared theta, then if we were to subtract tangent squared theta to both sides, then what we get is 1 is equal to secant squared theta minus tangent squared theta, and that means we can substitute this 1 in for the secant squared theta right here. So we're going to end up with a 1 is equal to a 1, which gives us a chickadee check, 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 check. What you need to do is you really need to keep these identities handy dandy, and then you're going to be able to, anytime you have like squares and you have two functions like this, you're going to need to use your trig identities right here, okay, your Pythagorean identities. And then if you have just no squares, and these are, you might have a square, I guess, but if you have monomials, then you can usually use some of your reciprocal identities to simplify. So we'll continue working on these. I know you guys will have a lot of fun because everybody enjoys verifying.